When we're working with text files, we can make use of different encodings. So we just saw how to use the files readAllText method and the files readAllLines method, where we use an overload that simply specifies the input file path. When we use these methods, .NET attempts to detect the file encoding. It does this by looking for byte order marks in files to determine the type of encoding being used in the input file. If .NET can't determine the input file encoding, it will use UTF-8 as a fallback. When using readAllText and readAllLines, we can also explicitly specify the encoding to be used. To explicitly specify a text encoding, we make use of overloads that allow us to specify an instance of the encoding class. So we could use this overload of the readAllText method that takes the input file path and the encoding instance. Similarly, the readAllLines method also allows us to specify an explicit encoding. To get access to the encoding class, we need to make sure we've got a using directive for system.text. One way to get instances of the encoding class is to make use of the encoding class's static convenience properties. These properties essentially return configured encoding types. For example, there's a static property called ASCII of the encoding class. This represents ASCII 7-bit encoding, and what this property will do is it will return as an instance of the ASCII encoding class. There's also the UTF-7 static property. As its name suggests, this represents UTF-7, and this will return as an instance of the UTF-7 encoding class. Similarly, the UTF-8 property of the encoding class represents UTF-8 encoding, and this returns as an instance of the UTF-8 encoding class. We also have the Big-Endian Unicode property. This represents UTF-16 encoding in Big-Endian byte order, and behind the scenes, this returns a configured Unicode encoding instance. There's also the Unicode static property. This represents UTF-16 Little-Endian. Once again, this returns an instance of the Unicode encoding class, this time configured for Little-Endian byte order. The encoding class also has a static property called UTF-32. This represents UTF-32 encoding with Little-Endian byte order and ultimately gives us an instance of the UTF-32 encoding class. In addition to using the static convenience properties of the encoding class, we can also directly instantiate the different encoding classes, such as the UTF-32 encoding class. So if we look at some example code, we need to add the using directive to system.text, and then we can call the file readAllText method, passing in the input file path, and this time explicitly specifying that the input file is encoded with UTF-32. Similarly, with the readAllLines method, we can specify an encoding. In this example, we're specifying ASCII. If we wanted to specify UTF-32 but with Big-Endian byte ordering, rather than using the UTF-32 convenience property of the encoding class, we can instead create an instance of the UTF-32 encoding class and specify true for the first constructor parameter, which will specify Big-Endian byte ordering. In the previous demo, we also saw the writeAllText and writeAllLine methods in action. By default, these two methods use UTF-8 encoding, and they don't output the byte order mark to the output file. There are overloads of these two methods that allow us to specify an encoding. And once again, if you don't want to use the static properties of the encoding class, or you want to specify some custom encoding, you can do so by creating an instance of the specific encoding class and configuring it. In this case, we're using UTF-8 encoding, and we're specifying true in the constructor parameter to actually output the byte order mark.